welcome to one more topic on our channel, Euclid Mathematics, which is solely based on ring theory. We have started lecture series on ring theory, linear algebra, calculus of variation, real analysis, and other subject too. So CSIR net exam is coming, so I felt that we have to solve multiple and different type of the example along with the topics also. So here in my today's video, I will explain to you all one of the basic and important topic from ring theory, which is a ring with a unity. So how one can find a ring with a unity. So how we can define whether ring is having unity or not. Okay. So first of all, let's understand the definition of a ring with unity, and then we'll move further for some of the examples depend on this topic. So now let's get start our today's lecture. Definition of a ring with a unity, it says that a ring, so we are having a ring here, r under addition dot, okay, it is a multiplication. It's said to be a ring with a unity, okay, if there exists non-zero element, okay, non-zero element identity which is belongs to our ring such that any element a into that identity which is equal to identity into that element, okay. So ae which is equal to ea need to be whole, then we say that e is the unit element of our ring and a is which is from our ring, okay. So e need to be non-zero, and one more condition, a into e which is equal to e into a need to satisfy, okay. So this is the only definition for ring with unity. Let's see some of the example, so in order to get this concept more clear, okay. Now here in my example, I taken here first z, q, r, c and Gaussian integer is a ring with a unity or not, okay. So let us see it is there or not unity element, okay. If I consider 1 belongs to r such that a into 1 and 1 into a which is equal to a, okay, and all a from r, okay. So any element you consider from these one groups, okay, z, q, r, c, z, I, and take the element 1 under multiplication, then we say that a into 1 or 1 into a which is equal to a. So we can easily say that 1 is the unit element which is a non-zero as well as it satisfies second property, okay. So we have the property with unit element need to be a non-zero and it hold that second property a into e which is equal to e into a, okay. So that one element which belongs from our ring and it hold this both property, one is non-zero and a into 1 which is equal to 1 into a. So hence we say that r, okay, r anything you may take, z, q, r complex z, I, okay, is a ring with a unit element as a 1, okay, 1 is a unity. So here now let's go for one more example. So next I taken here a ring as a q cross r, okay, is a ring with unity or not. So we have to find out whether this ring possesses unity or not, okay. Or you may take any element, one it is from q, one it is from r, so easily any element you take from this ring and multiply them to 1 into 1, so we will always get that element itself. So if I consider here ab, so unit element it is here order pair 1 1. So why in the form of order pair? Because we all are having the element in the form of order pair. So unit element is also similar like in the order pair, okay. So a into a comma b dot 1 into 1, okay. So take their multiplication of corresponding element a into 1, b into 1, okay. So a into 1 is a, b into 1 is a b. So we can write here a into e which is equal to ab, okay, or e into a which is equal to ab also. So it is easier to show that q cross r the ring which is having unit element 1 1, okay. So it possesses also unity, okay. So similarly you may try for z cross z, q cross z, q cross c, zi cross z, zi cross zi, all are the unity, all are the ring which is having unity 1 1, okay. So this is the second example. Let's go for one more different example. So here in my next example, I explained a ring as a q cross singleton 0 is a ring with a unity or not, okay. So q cross singleton 0, how it is having the element of a type. So q I taken as a from q. Maybe q possesses any element, 0, non-zero, anything, okay. So I taken as a may be 0 or non-zero, but in a second element here, singleton 0 or in curly bracket singleton 0, it possesses only one element which is a 0. So that's why order pair a0 it is there in q cross 0 and a from the q and 0 it is from 0 itself, okay. And we have to show that q cross 0 is a ring with unity or not. Now let's find out whether it possesses a unit element or not, okay. So for unity we always take the element which is from the ring, okay, which is from the ring, and when we multiply that to the other element it gives us ab is equal to ba, okay. So 0 0 I taken here I taken here 1 0, which is a non-zero unit element. Okay, 1 0 is a non-zero unit element. Okay, so its second is a 0, but first is non-zero. So we say that this order pair is non-zero. Don't get confused about the second element. Second element, it shows that 0, but first element is non-zero. So we claim here that 1 0, it is always non-zero element from our ring. Okay, so 1 0 is a non-zero element. Okay, it's not equal to zero element. Okay, 1 0 is a non-zero element which is from our ring Q cross singleton 0, and we have to find out the element, whether that element it is holding identity property in our ring or not. Okay, so I consider here a0, multiply a0 into 1 0. So what we will get, a into 1 it is here, 0 into 0 it is there. Okay, so a into 1 a, 0 0 0. Okay, so a 0 1 0 we get the a into 0 itself. Okay, so if we multiply a0 to any element, we will get that element itself. Okay, so or instead of that, you may multiply 1 0 into a0, you will land on only a0. Okay, so this is the only 1 0 unity of a Q cross singleton 0, and hence we say that Q cross singleton 0 with unity which is a 1 0. Okay, now similarly you may try for the another example too, like R cross singleton 0, complex cross singleton 0, Z cross singleton 0, Gaussian integer cross singleton 0, all are the unity, all are the ring which is having unity 1 0. Okay, now one more example, last example here for this topic. Okay, let us see R which is equal to Zn is a ring with a unity or not. Okay, and if it is a ring, then why, and if it is not ring, then why not? Okay, now Zn why it is not a ring? Okay, if I consider any element Z1, okay, if I consider Z1, okay, which is having only element singleton 0, and if I consider here the any element from Z1, it is only the possibility 0 here. When it is not there, so non-zero element it is not possible. Okay, if n is 1, then Z1 is equal to 0, and then non-zero non-zero element not possible there to hold our property. So it is not a ring with the unity. Okay, so if I consider here n which is equal to 2, then 1 belongs to Zn. 1 it is there. Under Z2 there is a 1 always exist, or Zn there is a 1 always exists, such that a into 1 which is equal to 1 into a. So Zn is a ring, always ring with a unity, but n need to strictly bigger than 1. Okay, how we want the n? N we need strictly greater 1. Okay, this property need to hold. If n is equal to 1, then it is not ring with unity. Okay, so this is the only Zn we say that it is not a unity. Okay, when n is equal to 1, Z1 is not unity, but when n is equal to 2, Z1 is a Z2, and Z3, Z4 all are the unity. So what happen if I take a cross product? If I take a cross product of Z modulo n, okay, like a Zn cross Zn, which is a ring with a unity or not. Okay, so if we take Z1 cross Z1, so it always gives 0 0 as a possible chances. So for Z1 it is not a ring. Okay, it is n is equal to, it is not a ring, but if we take n bigger than 2, it always possesses a unity element. Okay, and Gaussian integer modulo I, Zn I. So if I consider Z1I, it consists only the 0 0 element. Okay, so it is a ring with unity, it need not. Okay, so it is easier to prove. Already I explained the Gaussian integer modulo n in my previous lecture. Okay, so we have to take the element here in a Z1I. Okay, Z1I gives a 0 0 element. Okay, so it possesses only 0 0 element. That's why we say that non-zero element it is not there. Okay, that's why we say that unity element does not exist. Okay, so this is only for the today's lecture. I explained here ring with a unity in my today's lecture, and some of the examples with the definition. Okay, it's quite easy topic, just need to understand only the definition, and I explained all different type of the example depend on my today's definition. Okay, so I hope so you all have understood my today's lecture. Nothing is difficult here, and even after you found anything difficult, let me know in comment section. I will come up with the different videos. So thank you everyone, thank you for my today's lecture.